Imagine you step into a spaceship and fly straight toward the darkest object in the universe. Not a planet, not a star, a hole in space itself. As you fall closer, something strange begins to happen to time, to light, and to your own body. So what would actually happen if you fell into a black hole? The answer is stranger than you think, and it might not end the way you expect. Let us start with what a black hole really is. It is not a cosmic vacuum cleaner sucking everything in. It is simply a region where gravity has become so strong that nothing, not even light, can escape. That is why it looks black. Light goes in, but it never comes back out. A black hole forms when a massive star dies and collapses in on itself. All that matter gets crushed into an unimaginably small point, and around that point sits an invisible boundary called the event horizon. Cross it, and there is no turning back. Ever. So now picture you, in your suit, drifting toward one. From far away, nothing dramatic happens at first. You do not get pulled in violently. Gravity follows the same rules near a black hole as it does near any heavy object. If you stayed at a safe distance, you could orbit it just like a planet orbits the sun. But you are not staying at a safe distance. You are falling in. And as you get closer, the difference in gravity between your head and your feet starts to grow. Slowly at first, then not slowly at all. Here is where things get uncomfortable. Near a black hole, the part of you closest to it feels much stronger gravity than the part farthest away. Your feet get pulled harder than your head, so you begin to stretch. Scientists have a name for this, and it is wonderfully grim. They call it spaghettification. You would be stretched longer and thinner, like a strand of pasta pulled from both ends. For a small black hole, this would tear you apart long before you ever reach the center. For a truly enormous one, you might actually survive the crossing. We will come back to that, because the size of the black hole changes everything. With a small black hole, the gravity changes so sharply over a short distance that you would be ripped apart outside the event horizon. You would never even make it inside as a whole human being, but a supermassive black hole, the kind sitting at the center of galaxies, is different. It can be millions or billions of times the mass of our sun. Its event horizon is so vast that the change in gravity across your body would be gentle, at least at first. You could cross the boundary completely intact and not feel a thing. You might not even know the exact moment you passed the point of no return. Now let us talk about something even weirder. Time. As you fall toward the event horizon, time does not behave the way you expect. To you, falling in, your watch ticks normally. Seconds feel like seconds. But to someone watching from far away, something bizarre happens. They see you slow down. The closer you get to the horizon, the slower you appear to move. In fact, from their point of view, you never quite cross the boundary at all. They would see you frozen there, hovering at the edge, fading and dimming, your image stretched and reddened until it slowly disappears. To them, you hang at the edge forever. To you, you fall right through in moments. Two completely different stories of the same event, and both are true. And the view, if you could survive to see it, would be unlike anything else in existence. As you fall, the light from the entire universe behind you would bend around the black hole. The sky would warp and curve, stars would smear into rings. The whole cosmos might appear squeezed into a bright halo above you, while below sat pure darkness. For one strange moment, you would be looking at the universe in a way no human has ever seen it. But what happens once you are inside? Once you cross the event horizon? This is where honest science has to admit something. We do not fully know. Inside the event horizon, our best theory, Einstein's general relativity, predicts that all paths lead to a single point at the center. A point called the singularity, where matter is crushed to infinite density and the math itself breaks down. And here is the truly unsettling part. Once you are inside, falling toward that center is no longer a choice. It is not a direction in space anymore. It becomes a direction in time. Just as you cannot avoid moving into next Tuesday, you cannot avoid moving toward the singularity. The future itself points inward. So what would the end actually feel like? For a small black hole, you would be torn apart by tidal forces long before this point. For a giant one, You might travel deep inside, intact, with the universe glowing behind you until the rising gravity finally stretched you beyond what any body could survive. Either way, the journey would be short, and no signal you sent, no light, no message, no cry for help, could ever reach the outside world again. You would be gone from our universe completely, and now we can close the loop. What would happen if you fell into a black hole? You would not be sucked in violently. You would fall, gently at first. Time would betray you, fast for you, frozen for everyone watching. The universe would bend into a halo of light above your head. And then gravity would stretch you into a thread and pull you toward a point where everything we understand stops making sense. To the outside world, you would simply fade at the edge and never be seen again. To yourself, the whole thing might be over in seconds. A strange death, a stranger view, and a one-way trip into a place the laws of physics still cannot fully explain. If you want to keep exploring the universe with us, subscribe, because there is always something stranger out there waiting. And next time, we are asking an even bigger question. What came before the Big Bang? The answer might change how you think about time itself.